Okay, so in our last class, we just started our discussion on SVM support vector machine. And we have already found the equation for the support vector machine to solve, and that equation is optimization equation. Okay, that means we have to minimize this and such that this is the condition, okay, the constants. So in optimization function, usually we write this one. This is called objective function. This part is objective function. This is minimization of what? The minimization here is W, and this is the same as the maximization of 1 by W. So here's 1 by W. This W is actually our Euclidean norm, okay? And 1 by W, this one is what? This one is the this one is our margin. So we want to maximize the margin based on this. That is, we need to find out the support vector, and we want the higher accuracy, okay? Higher accuracy. So to find out the support vectors, we need to minimize the distances, okay? And the distance minimization means actually we need to select the support vectors which are closer to the hyperplane, and that's why we have to minimize the distance. And to find out the support vectors will be within the minimum distance of our hyperplane. So that's why this equation. Okay, in our last class we have discussed in details, and also we finally formed this equation. This is called the SVM with hard constants. Now we want to solve this equation using optimization theoretic approach. And here, what's our target? The target is to find out the optimal value of W and the optimal value of B. So we know that what's the W and what's the B. Now, according to our optimization problem, this is optimization problem. Here's a minimization of this subject to this constant. Okay, this is the constant. In our last class, I have started this discussion. That means at first we need to form the Lagrangian equation to find out the optimal value of W and B. So Lagrangian equation usually we form like at first we need to write our objective function, and then minus of, we have to add the Lagrangian constant alpha and then the constants. So this is C1 if we have one constant like C1. If we have many constants, then again we have to maybe add alpha. So if we consider this one is alpha 1, this one is alpha 2, and then here is the C2, that is constant number 2, like this way. Okay, so this is the original form of forming Lagrangian equation from the objective and constants. Okay, so here we can see that the constants in this case, it is inequality constant. Inequality means here is greater than equal something. Okay, at first we need to make it equality constant. Equality constant means that is yi, this one we have to write like, just if we take this one in left side, then it will be like -1. Okay, -1 equals 0. So then it will become equality constant. Okay, then what we have to do, we have to form the Lagrangian equation. And as I already mentioned, at first the objective function here, this is the objective function, and then minus of, we can see that yi and xi, that means many constants are there. So what we have to do, we have to sum of those, that is negative summation of alpha I, here is the yi, and wxi plus b minus 1. Okay, the equality constant. So this is the equation of our Lagrangian equation, forming the Lagrangian multiplier equation. Okay, now we have to that is follow few steps to find out the optimal value of W and also that is the B. And here is another thing, additional thing, that is Lagrangian multiplier. So that is our Lagrangian constant. this alpha. So we need to find out the value of alpha also. Okay. To find out the W and B, we need to find out the alpha also. Now at first, we have to take the derivative of this equation. Just we know that for finding out the optimal value, we have to say that this one is 0 and then take the derivative. Okay. So we have to take the derivative of this equation with respect to what? With respect to B first, at first B. So if you take the derivative with respect to B, in this case, what we will get? Here we can see that this is the case. So here it is half then W. So this one is here is a square and minus of summation of I, then alpha I, here is yi, then here is the omega or the W, and then xi plus of B. So yi, here it is square, plus of B minus 1. This one equals 0. Then if we take the derivative, so this is our L Lagrangian equation. If we take the derivative of this function with respect to B, then we can see that this term is constant. Okay, so we can write just 0 and minus, here is the summation of, there is the I, so alpha I yi, here is W and X. From this part we can write, actually we can write, so it is, if you multiply with those things, that is here is alpha I, and then it is yi, then W the vector, then xi the vector, that is our feature vector, plus of, this is y and here is b. Okay, that means you can see it will be yi b. So this part, and then minus of 1, this one. Okay, so now if we consider the alpha I also, if we multiply with alpha I, then it will become alpha I, so we will get alpha I yi, then W x I plus of, here is the alpha I yi, and also alpha I yi and b, and minus 1. Minus 1, here is alpha I, that means alpha I minus alpha I, this one. But we have the summation here. Okay, the summation, this symbol, summation symbol. So here is the summation. That means we can also write like it is summation of alpha I yi, then w, then xi, the vector, plus of this summation. We have to carry out this summation. So here that means summation alpha I yi b and minus of summation of alpha I. Okay, so that means from this part, so we will get actually this one. Okay, we will get this one. So as we are taking derivative of this equation, so L with respect to B, then it will be like, so if we can write it here, so it will be delta L by delta B. So this part is constant, okay, because we are taking derivative with respect to B. So this part it will be 0 minus of then minus of this. So in this case, we can see that we are taking derivative with respect to B. There is no B in this section. So all these are just constant. Okay, all these are just constant. So that means we will get here just 0. Okay, and then we can see see it here like this part. So this part, it is summation of alpha I. So that means we can say that we have to write here summation of so here is a b. So that means if we take the derivative with respect to b, then we will get only the summation of alpha I and yi and just 1. Okay, so b is 1 and minus of the alpha I here, this is constant, also 0. Okay, so dl by dv, that means we can say derivative of L, so derivative of b, delta b, we will get this. And as we can see that actually we have to set this equal 0. So it means that we will get this summation of alpha I yi equal just 0. Okay, so this is the equation we will get if we take the derivative of L with respect to b. So here is this, that is alpha I yi equal 0. So that means if we take the partial derivative of this equation, then we will get this. We will get just the it is equal 0. So we know that is in our any data set that is yi is what? This yi is the original class levels. Y is the original class level, and for a binary classification problem, it will be -1 and +1. Okay, there is no and yes. And here alpha I equals 0. This is for non-support vectors because we form this equation only for the support vectors. Okay, so that means that the W we want to just draw the perfect line, or you can say hyperplane, based on what? Based on the support vectors. So for non-support vectors, the Wi here is the alpha I, it will be 0. Okay, it will be 0. So that means this is the first equation we got from our Lagrangian equation. Then the next thing is what? Next thing, again we want to take the derivative of the function, this time maybe with respect to w. So if we take the derivative of this equation with respect to w, then we will get the first thing, you will get the summation of alpha I. Just similarly, okay, just take the derivative of this equation with respect to w, then we will get alpha I yi and xi equal w. This is another equation we will get. So we can say that this is equation number 2. So xi, we can see this is xi. Sometimes what we need to do, sometimes we need to apply some transformation function to change this xi to some other that is feature space. To transform this x to some other feature space, we will see that actually. So on that case, what we have to do, instead of x, we have to just use phi of x. Phi of x means this is the transformation function. Sometimes we also call it linear, the kernel function. And we need to apply the kernel function. Then this equation will be the same, okay? The equation will be the same. So that means instead of xi, we have to just apply the kernel function to transform this xi to a new place, or we can say new feature space. Okay, so this is another equation. Okay, another equation we can get from that is the that is our Lagrangian equation. And now by solving those equations, we will get the solution. Okay, so some other things we need to maybe find it here. That is, so we can see that this is our first equation. Take the derivative with respect to b, and second equation by taking the derivative with respect to w. And some other things in our constant is this, that is the decision boundary. Okay, the decision boundary, or we can say our hyperplane equation. So we know that the hyperplane equation is this: w transpose x plus b. Okay, so w transpose x plus b, and greater than or equal 0. Okay, so greater than or equal 0, that means the positive for all the cases. And this is the same. That means we can see now, that is, if we put the value of w here, where we can get the w? According to our equation number 2 here, you can see this is the equation. If we put the value of w equal summation of alpha I, yn, and xi. Okay, so here is this. So here is the summation of alpha I, yn, and xi, this part, and this is our, that is the vector x, that is feature vector x. Here is the feature vector x plus b equal. That means this equation, we can rewrite this equation in this form by putting the value of w here. Then we will get this one. And this one actually we can rewrite also in this form. That means here xi, and here is the x. So here is the xi, here is the x. So a function, that means we can see that this is a function. This is a function of what? Actually, we can say x and xi will be just two vectors. Okay, two vectors. One of x vector, another xy vector. That means we need to multiply these two vectors, kind of vector multiplication. So this is the function, that means for the vector multiplication. Okay, so that means another equation, we got this equation. This is the equation number 3. Now we need to think about the positive garter. So as I have already mentioned also the garter in our lecture, so we can see that if this is our the decision boundary, or we can say hyperplane equation, w transpose x plus b equal 0, then if we consider that these are negative, then we will get a negative garter. That means we can see if we consider these are negative and these are positive, then that means this is the support vector. This is the support vector on our negative side, and this is the support vector on our positive side, and this is the support vector on our positive side. Okay, so if we consider a garter, that means this is the garter, this is the garter. We can see this a parallel line to our hyperplane equation, or we can say line equation here. Okay, separator line. Then it will be the w transpose x plus b equal -1. We can see this is the negative side, and it will pass through the negative support vector. And similarly, we can think about also positive garter, like this is a positive garter. So this positive garter will pass through the positive point. Okay, so this is our positive point, and we can see that w transpose x plus b equal +1 on that case. And we already know that there is the hyperplane. It should be placed at the middle. Okay, middle. That means from the positive garter to our hyperplane, if we consider that one is gamma, the gamma is what? Gamma is our margin. Okay, margin. and then this is just gamma, and from positive hyperplane to the positive gutter is also gamma. Okay, so hyperplane to negative gutter is gamma, hyperplane to positive gutter is also gamma. Okay, gamma, that means uh, uh, as we discussed in our last class that we have to place the hyperplane at the middle. Okay, at the middle. So what we can see here, that means positive gutter and negative gutter. So those equations we have to consider here also. So for the positive gutter, we can see this is the case, W transpose X or Wx plus of B equal 1, positive gutter. So again, we can put the value of W here, then this is the W. And then again, we can convert to this function. This is the K, Xi and X. So it is just the vector multiplication of two vectors. And considering the negative, so we will get the equation number 4 from here. And then negative gutter, if we consider the negative gutter, so here is the same thing, W transpose X, then we will get this the similar function. Okay, the similar function. And another thing is width of the margin. Okay, width of the margin. So we know that the width is actually 1 by our W. Okay, so this is the width. This W is this is the Euclidean norm. Okay, this is the width. So we can see that this is the margin. So this is gamma. So gamma is our margin. So the width actually 2 gamma. Okay, 2 gamma. We can see that that is width of our road or plane. We can see this is gamma. This is also gamma. So total the width will be it will be 2 gamma. Okay, 2 gamma. So that's why the equation you can see here, we can also derive another equation from that. It will be the 2 gamma. So that means this times 2. That means 2 by our W. This W is our Euclidean norm. Okay, 2 by this Euclidean norm. So here is this is the case. And we know that there is the Euclidean norm is this square root of summation of W I square. Okay. So this from this we will get another equation. So that means from our Lagrangian, we will get two equations by using just taking the derivative and setting the value equal 0, and some other equations we will get from our that is the constants, and also from our that is positive and negative gutters. Okay. But now what we have to do, we have to use those equations to solve our, that is the problem, the learning problem using support vector machine. So let's say the one problem, the data sets are given. Okay, so maybe you can say that that is the data sets are given, or we can say the plots are given, that is scatter plots are given. So like maybe some points we will get here, there, and some points we will get maybe here, there, something. Okay. Now what we have to do at first we need to think about our about our support vectors. Okay, the support vectors. So at first we need to think about our support vectors. So on that case, what we have to do, like you have to think about, like if we can draw our hyperplane like this way, so consider that we can draw this way, or we can draw also in another way, like maybe we can draw by this way. Okay, so several support vectors and several lines or several separators we can consider. So consider that maybe you can say just our support vector, sorry, our hyperplane will be like this. So on that case, what we will get? We will get the support vector. So support vector, you can see maybe from the positive side, this one will be the support vector, which one is closer to a hyperplane, and maybe this one will be a support vector from our negative side, and also this one will be our support vector from the negative side. So consider that this one is A, this one is our B, and this one is our C. Okay, the three support vectors we have. So in this case, that is the from the negative side, we will get like A and B. So here is this, we have assumed that A and B, and for this case, this is actually the two-dimensional problem. Okay, two-dimensional problem, X and Y, we have X and Y. So each and every A, it has maybe the two values. Okay, so consider that like A is 0 0, B is just 1 1, and C is 2 0. Okay, C is 2 0, C is 2 0. So those are the values. That means in our data set, several points are there, but if we select the support vectors, we will get the three support vectors. Okay, three support vectors. So in this case, we have like the data set will be like this way. That is x1, and maybe you can say this is y, x and y, like okay, so x1, x2, something. Okay, x1, x2. So the points are given like maybe this is the 2 2, and this is 4 2 something, and also we have like 0 0, and then maybe 1 1 and 2 0, and maybe 3 2 something. Okay, so this is given, and also the data that is called the y is also given. Y is what? Y is our original class level. The original class level, this is 2 and 2 may be positive, and 4 and 2 may be negative, and 0 and 0 and the negative, and 1 and 1 is also negative, 2 0 is positive, and 2 3 is negative something. So this is the data. If the data set is like this, so from this data set we can plot like this way. Okay, and we can see that we have that is so here is the C. In this case, C is 2 0, so that means this one is selected as our support vector, and also 0 0, this one is selected as our support vector, and also 1 1 is selected as the support vector. So that means from the data set we can select the support vectors. Okay, so these are our support vectors. So if these are our support vectors, then how can we find out the optimal value of W and B using our Lagrangian multiplier? And as we can see that we have additional the Lagrangian constant, so that means we have to find out also the values of Lagrangian constant alpha. And if we find out the alpha, then we will get the W and B. And for the solution, here is the step 1. Compute all kernel function values, which in this case, these are all dot products. Okay, so that means as we have seen in our equation, you can see here's the k. Okay, this function is xi and x. If we consider this one xi and x just a vector. Okay, so it is a multiplication of two vectors. So here it is, that is k. We have a, b, and c. So we can find out the combinations of all of our support vectors, like the functional value of a and a, then a and b, then a and c, then b and a, b and b, b and c. So that means we can see that we want to find out, here is the a, here is the b, and here is the c, and this is also our a, this is b, and this is c. So the value of our function that is kaa we want to compute. So in this case a and a, okay. So we can see a and a. The a is 0 0 and a is 0 0. Okay. So that means we can see it will be uh, to multiply this one. What we have to do, a and a. So this is a. This is also a. So if we multiply these two, then this 0 times here is 0, okay, 0 times 0, and this 0 times this is also 0, 0 times 0. So that means we can see that 0 times 0 here is the 0 times 0 plus of 0 times 0, it will be 0. Similarly, if we want to multiply AB, so this is a, now B in our case, B is what? B is our 1 and 1. So B is 1 and 1. So instead of A, if we consider here the B, then 0 times 1, here the 0 times 1 plus of 0 times 1, 0 times 1, it will be 0. Similarly, we can also consider AC. Okay, AC, then we will get 0. If we consider KBA, so KBA, then similarly we can multiply like KBA and KBB and KBC. Okay, so that means we can easily compute this. So this is our step 1. Then in step 2, what we have to do, the next thing is, in step 2, write out the systems equation using the SVM constants. So we have already that is determined those equations. The alpha I yi equals 0. We got that one. You can see this one is the equation. Okay, alpha I yi 0. This is constant number 1. So here we have written that this is constant number 1. And then second constant, it is the positive gutter. Okay, so the positive gutter, we already have seen this equation. There is constant number 2, and third constant here is the negative gutter. Negative gutter. Okay, so using these 3 constants, we have to form now the equations. Okay, equations. So at first we can see that this is the constant one, constant one, constant one. So using this constant, we can see that what we have to determine, alpha we need to determine, and also we need to determine the B and W. Okay, so at this case, using these three constants, we want to form the equation to find out the values of alpha. Okay, find out the values of alpha. And now we can see that the alpha in this case, alpha I yi equals 0. It means that actually this one is true for all of our support vectors. So we have 3 support vectors. We have 3 support vectors. One is A, another one is B, another one is C. So if we put the that is, if we pass here this equation using our that is A, okay, and then we have the equation like the A, B, and C. We have A, B, and C. A is what? I can maybe rewrite this. A is 0 0, B is 1 1, and C is 2 0. A is 0 0, B is 1 1, and C is 2 0. Okay, 2 0. And this two is from the negative class, and this one is from the positive class. Okay, so positive class, positive class. Now we can see that is alpha I and yi. So alpha I and yi. So in this case, we can see that alpha I, if we write this equation, then it will become like alpha A times what? yi. Okay, yi is what? Yi is our class level. So yi in this case, a is negative class. So that means here the negative one. Then plus of, if we uh, pass it through like the b, then we will get here is the b is alpha b times it is also negative class, plus of alpha c times it is positive class. Okay, positive one. And we don't have any b here. That means we can see there is 0 times b. Okay, 0 times b equal what? Equal 0. So here is the equal 0. So this equation we can write in this form. Okay, this equation, this is our c1, that is from the constant one. From the constant one we can see here is the negative alpha 1. This is negative of alpha 1. There is a coefficient and alpha, plus of negative alpha b. Here is the coefficient negative 1 and alpha b, plus of there is 1. So 1, this is positive 1 alpha c. So positive 1 alpha c, and then 0 b. We don't have the b here, and equal what? Equal 0. Equal 0. Okay. So this is actually the equation we will find from the constant one. Now, the positive and negative order. So we can see that there is A and B. These two are from the negative class. Negative class. That means these two, the negative gutter will pass through A and B. These 2 points. These 2 points. So if it pass through just the A, what will be the case? If it pass through the B, then what will be the case? So that means the negative gutter, the constant number 3. Now we can see this is the negative, because negative gutter, it will pass through these 2 points. If it passed the C3, the constant 3, if it passed through the A, then what will be the case? So in this case, again, we can see here there is yi. Here is the yi. Yi is what? Yi is negative. So we can say yi is negative. Yi times k of xi and x. Xi and x. So xi and x, we can see that there is for xi and x we have here, there is the a. Okay, considering the a first. So that means in this case it will be ya, that is uh, uh, class level of a, times k of a, and then it will be the negative 1 times k of a. We have already determined the values of k of a. So that one is, we can see k of a is 0. So we can put that here, times and so we can say the alpha a. If we rewrite this equation in this form, then we will get the same thing. That is yi and kaa. Then if we multiply these two, then we will get 0, and then this one. And the next, that is, we can see that the yb and also kba. Okay, kba, because we can see here a, we have considered the a. So in this case, the xi, you can see xi is, at first xi is a, and then now xi is b, and next xi will be c, but x will be the same. We can see x will be the same because here we consider a. Okay, so now yb times kba, we will get 0, and then alpha b plus of, similarly yc kca, then we will get the 2 alpha c. And in this case we can see we have b, so the coefficient of b is 1. So here is the 1 b, and then equal negative 1. Okay, so here is the negative 1. So if we pass this one to the a, now if we consider that if it passed to our equation b, so that means in this case this x will be the fixed, this x is what? X is b, and we can change the xi. At first we consider the a, so ya, again you can see b here, yak ab, and also we will get the 0 alpha a, Similarly for BB and for CB and alpha C. And finally, we will get that this is also negative 1. And then if we consider the constant that is 2, so we have another point that is the C. If we pass this constant, if this constant pass through the C, then we can see C2 is C. Just only one data point in our there is the positive support vector. So positive support vector. Then again you can see this is the equation for that case, the constant number 2, and here is x is our C. X is our C, and xi is A, B, and C. Okay. So at first A. So A, alpha A, and we can see Y A. Y is what? Y is this time is positive. Okay. So positive. Here is the and then the KAC. So KAC is 0. Okay. So KAC is 0. So we will get here like 0, and then in this case we will get so here is 1 minus 1 times 2 is negative 1, then alpha B, and similarly we will get this equation. Okay, so that means considering these three support vectors and considering our constant 1, 2, and 3, we will get these 4 equations. So we can actually rewrite those equations here. So C1 is what? Negative alpha 1. So here is the negative alpha 1 plus of negative alpha B. Here is the negative alpha B, and plus of positive alpha C. Positive alpha C is equal to 0. Similarly, alpha, so from this equation, we will get like 0 alpha A. So here is the 0 alpha A. And then 0 alpha B. So 0 alpha B. And 2 alpha C. So 2 alpha C equal, so plus of 1 alpha B, 1 B minus of 1. So minus of 1. So in this way, we can rewrite those equations. Okay. And now we can see that actually what we need to know, we need to know alpha A, alpha B, and alpha C, 3 values. Sorry, alpha A, alpha B, alpha C, and B. Okay, so we have 4 values here, and we have also 4 equations. So that means we can easily, solving these equations, we can easily get the values of alpha A, alpha B, and alpha C, and also B. Sorry. So here we can see there is alpha A, alpha B, alpha C, and also our uh, there is our B equal minus 1. So we already got the equation that is alpha A, alpha B, and alpha C, and also our B. Okay. So in this way we can find out the values of alpha and also the B. Uh, Hello.
Yes, sir.
So do you have any question? তোমাদের
No,
কোনো
sir. No
question আছে কি?
question from me, sir.
Okay. So I have to stop my class here because today we have actually the admission test for master's exam, and I am one of the invigilator for that. Okay, so now I have to maybe move for the invigilation. So we will start our discussion. That is from this slide. That means if we have given a problem, then how can we solve that problem using our Lagrangian equation uh, using support vector machine. Okay. So thanks all of you for joining this session, and see you in our next class.
Okay, sir. Assalamu alaikum.